In this video, we are going to discuss about differentiator. So, the differentiator is to perform the mathematical operation of differentiation. That is, the output voltage is a differentiation of the input voltage. So, this operation is very useful in order to find the rate of change of the signal, which varies with the time. So, let us now discuss about the basic or ideal differentiator. Okay, here you can see the input is given at the inverting terminal, and if we compare with the ideal integrator, the R and C get interchanged, right? Let me take this, the current flowing through this one is IC, and this one is IF. Okay, so I can write both the incoming current, right? Um, I can write this IC current is equal to IF at this point, right? So how to write the current flowing through this capacitance? I can write it as C dVi divided by dt, right? Because this voltage is 0. Okay. So how to write this one? This is nothing but 0 minus V naught divided by RF. You can. So I can now write what is V naught. V naught is equal to minus RF C1 dVi divided by dt. So you can see the differentiation of the input voltage is nothing but V naught, right, into RF times C1. That is a negative value. Okay. So uh, so if I write it in terms of j omega, so I can write this is minus R of C1 into j omega VA, right? So what is V naught by VA? V naught by VA is equal to minus R of C1 j omega. So this I can write it as minus j 2 pi f into R of divide into C1, right? So if I take the amplitude of this magnitude of this one, this is nothing but my gain, that is equal to 2 pi f R of C1. Okay, so this I can write it as f divided by fa, where my fa is nothing but 1 divided by 2 pi R of C1. Okay, so if I plot the diagram, so if at f is equal to fa, if you substitute f is equal to fa, my a becomes 1. Okay, so if I take the 20 log of a value, I will get answer is equal to 0 t, right? So if I draw the diagram, okay, for frequency and my gain, right? So it is 0, it is in dB. Okay, it is in 0 when our f is equal to fa. Okay, and this is nothing but my open loop opamp, opamp response. Okay, this pink line. Okay, so let us now discuss about the limitations of this So once if it reach this value, okay, this is let me take this is 20 and this one is minus 20 like that. So once it started this value, it start if I increase the frequency, the gain get decreased. Okay, it will not increases further. Okay, so that is a limitation of the basic outcome. Limitations or drawbacks of basic differentiate. So it is susceptible to noise. Okay, since the input noise fluctuation of the small amplitude will have larger deviations. Okay, uh, you can see if gain is increasing, if gain is increasing, the stability get decreased. Okay, it get decreased. Okay, so here the input impedance of the differentiator is x of xc, right? Input impedance of differentiator is xc, right? So if I increase the frequency, for increase in the frequency, right, this xc get decreased, right? So at high frequency, the stability get decreased, right? The stability get decreased and the gain get increased, right? So due to the instability, and it also goes to oscillate, right? So in order to avoid that one, we have to employ the proper frequency compensation technique. Okay, in order to make it stable and to avoid the oscillation. Okay, and you can see it is sensitive to so it is amplify the noise, right? It amplifies the high frequency noise. That is the noise signal get override with my input signal, right? So it will amplify my high frequency noises. Okay, and there is a possibility that the noise can mask my actual input signal, which will lead to uh, saturation. Okay, so this is a problem. So what does here the saturation means? The output leads to distortion. So that is what here it means saturation. It does lead to a limited output C. And there are also other limitations that low frequency. There is a possibility that the capacitor is open circuited. The capacitor C1 is open circuited at low frequency. So there is a possibility that it it struggles to differentiate my low frequency signals. Okay, so in order to avoid these problems, we are going for the practical differentiator circuit. So let us discuss about the practical differentiator circuit in the next video. Thank you.